On today's episode, the Artemis I's success vindicates the legacy hardware approach.
Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today.
With the successful launch of Artemis I, NASA is back in the crewed space exploration business again, with the largest rocket yet launched by anyone, anywhere. The combined 8 million pounds of thrust at launch exceeds the power of the Saturn V launch vehicle that carried a dozen astronauts to the moon. The vehicle for Artemis I is the Space Launch System, a large core stage with two jettisonable solid rocket boosters, the combination of which lifts an upper stage capable of propelling an Orion spacecraft or other payload out of Earth orbit. The Space Launch System is all new, but uses technology derived from Space Shuttle components with development histories that go back to the 1970s. Boeing builds the 212-foot tall, 27-foot diameter core stage, a lengthened and developed version of the Space Shuttle external tank, and like that application, it carries liquid hydrogen and liquid oxygen, but unlike the shuttle external tank, carries thrust loads from the engine section, which houses 4 Aerojet Rocketdyne RS-25 engines. Those engines are not only derived from the Space Shuttle main engine program, but for Artemis I, they're engines flown on previous shuttle missions. Although designed to be reusable, the Space Launch System is expendable, and future new-build engines will delete the reusability capability. The core stage is the largest rocket stage ever built, and weighs 2,300,000 pounds when full, with 733,000 gallons of propellant. Now, 2,300,000 pounds is heavy, but the 4 engines produce 2 million pounds of thrust. The solid rocket boosters provide the supplemental thrust needed to overcome the core stage, upper stage, and payload mass. Northrop Grumman builds the solid rocket boosters, which are upgraded Space Shuttle SRBs with an additional 5th motor segment. Like the core stage, the SRBs are record-breaking, the most powerful solid rocket boosters ever built for spaceflight. Each booster generates 3,600,000 pounds of thrust and consumes 6 tons of solid propellant per second. The twin boosters provide over 75% of total Space Launch System thrust capability at launch. The SLS is designed specifically to carry payloads out of Earth orbit, and the Artemis I mission represents the Block 1 configuration, carrying an interim cryogenic propulsion stage and Orion spacecraft as well as a launch abort system. The Block 1 configuration can propel 27 tons to the moon. The system can accept different upper stage and payload configurations, and future production blocks will carry a higher performance exploration upper stage capable of lofting up to 46 tons of payload out of Earth orbit. The Space Launch System is intended to be NASA's primary booster for the next 2 decades at least, but there is a commercial competitor in the very heavy lift launch market, and that's SpaceX. The SpaceX heavy lift system is called Starship, and when it flies later this year, will dwarf even the Space Launch System for booster mass and thrust, launching on a cluster of 33 Raptor engines, generating a cumulative 16 million pounds of thrust. 100 tons to low Earth orbit is predicted, and a private, commercial crewed flight around the moon is scheduled for 2023. Full reusability means that the SpaceX system is expected to be lower in operating cost, although no one knows at this point whether the new but reusable versus expendable mature technology race will create a clear winner. Both systems will coexist for years, and at this point the Space Launch System has taken an early lead. Which system will deliver the first humans to the moon after half a century will be determined in a year or two.
Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.